Hello Mathemaniacs, I'm the Math Edumacator. Today we're going to be discussing strategies for operating using negative numbers. Also, if you hear any strange high-pitched sounds during this video, it's actually the 4th of July right now, and there's fireworks going off, so just so you know. First, I'm going to talk about strategies for adding and subtracting negative numbers. For adding and subtracting negative numbers, there's lots of different strategies that you can use, more so than I can cover in just one video. So I'm going to share 3 particular methods that I think work fairly well and ones that I can illustrate without too much difficulty in just a short video like this. And I'll try to explain some of the advantages and disadvantages of each method as well. Method number 1, moving along the number line. Now, I talked a little bit about using the number line in my previous video on negative numbers where I had Billy demonstrate some problems. So we're going to go over that a bit more here. Here we have our standard issue number line. To the right, we have our positive numbers, and to the left, we have our negative numbers. If you take any addition or subtraction problem, what you want to do with this method is start wherever your first number is. So for example, if we had something like -1 plus 3, then we're going to start at -1 right here. Now to reach your answer, you're basically going to be walking from your starting point to some other point on the number line. And there's 2 very important bits of information to know in order to get there. First, check whether you have addition or subtraction. If you have addition, then you're going to be walking forward to your destination, but if you have a subtraction, you're going to be walking backwards. Secondly, check your second number. If your second number is positive, you're going to be facing in the positive direction, that is to say, to the right. But if it's negative, you're going to be facing to the left, the negative direction. The actual number will tell you how many spaces you need to move. So remember, for our problem, we're starting at -1, and we're going to be walking forward because our operation is addition. We're going to be facing to the right because our second number is positive, and we're going to move 3 spaces because our second number is a 3. So what would our answer be? So 1, 2, 3. And now I'm at +2. So -1 plus 3 is +2. Now suppose our problem is 3 minus 4. The way we illustrate that one is we start at 3, we walk backwards because we're subtracting, and we're facing to the right because our second number is positive. And our second number is 4, so we move 4 spaces. So 1, 2, 3, 4. And now we're at -1. So our answer to 3 minus 4 is -1. So what I want you to do at home is we're going to use this same method to try and illustrate -2 minus -4. So just take a moment, pause the video, and see if you can work out your answer using this number line. Everyone ready? Let's see how you did. First, we start at -2. We're going to be walking backwards because we're subtracting. We're going to be facing to the left because their second number is negative. And we're going to be moving 4 spaces because our second number is 4, or -4. So let's see where that gets us. 1, 2, 3, 4. 2. Is that what you got? If it is, great job. If you didn't get this right, you can go back and look over our rules again, or you could try using one of the methods that we'll discuss later in the video. So what are some advantages of using a number line? First, all you're doing is moving up and down the number line, so it's a little bit easy to work out visually. Secondly, I did point out in my last video that adding a negative is just like subtracting a positive, and subtracting a negative is just like adding a positive. Using the number line can help illustrate that, but you don't actually have to remember that in order to use this method, because you're using 2 different but related things. The operation tells you whether you're walking backwards or forwards, and the sign of the second number tells you which direction you're facing. It's easy to see that they're related, but you can use either one and you'll end up with the same answer. This number line goes out about 5 spaces in each direction, and normally most examples you'll see of number lines don't go out more than about 10 spaces. So if the numbers you're using are bigger than 10, it's not going to be easy to use this method. Plus, if the numbers you're using are bigger than 10, even if you drew a number line big enough, you'd be counting a lot. And that can sometimes get a little unwieldy. Method number 2, using integer chips. Last time I talked about how you can model addition and subtraction with counting numbers using these physical objects. If I add, I'm putting two groups together. If I subtract, I'm taking some away from my group. The good news is we can actually do this using integers as well, using negative numbers. We just have to find some way to represent negative numbers. So here's how we do it. Each yellow starburst represents 1, and each red starburst represents -1. So I can put these together and take them away just like I would with regular counting numbers. So before we get into any real examples, let's talk about something called a zero pair. We know that any number plus its opposite is 0. So if I had one yellow and one red here, then that would be the same as if I didn't have anything right there. So a positive starburst and a negative starburst together is called a zero pair because it's equal to 0. What's important about this is that I can add or take away any number of zero pairs to a number, and that number will still be the same. So for example, this is still 3 because each of these pairs is just 0. So I could put more here like that. I could take all of these away and I don't change the value of my number. This is very important. So the rules are simple. If I add, I put things together. If I subtract, I take them away. So here we have 6 plus 5. So if I put them together, that's going to be 11. I just count up how many I have. Now suppose I had something like -3 plus -4. Well, I would just put these together because I'm adding, and now I just count up how many -1s I have, and that's 7, so I have -7. Now suppose instead of both groups being positive or both being negative, I had one of each. So this is +9 and this is -5. So if I add these together, I just put them together like that. Now this is a little bit messy. So what we're going to do is we're actually going to count out and see how many zero pairs we have. So we have that one, this one, that one, that one, and that one. Now I can take away all of these zero pairs and it won't change my number. So I have 4. Let's try another one. +3 plus -8. If I put these together and then count out my zero pairs, 1, 2, 3. These zero pairs are each 0, so I can take them away, and I have 5 negatives left, so it's a -5. Now subtraction is where it gets a little bit more tricky. Let's say I had 8 minus 5. So I want to take 5 away from here. 1, 2, 3, 4, 5. Now I have 3. Same thing if I had negative numbers. -5 minus -3, I just take away 3 of these negative blocks. And so we have -2 left. Here's where the subtraction problems can get a little bit tricky. What if I had something like 6 minus -5? Now, so the problem is that normally I would take away 5 negative starbursts, but I don't have any here. What I actually have to do is add 0 pairs to my group here. Because again, if I take a 0 pair and put it with the group, it doesn't change this number. So I can do that as many times as I want. Now, 6 minus -5. If I put all these together now, again, the number hasn't changed because all I've added were 0 pairs. Now I have 5 red starburst. So now I can take them away to complete my problem. And what I have left over, if I do that, is 5, 10, 11. So that's +11. Now suppose we had -7 minus 2. Well, I can't take away positive 2 here because I don't have any positives. So I'm going to add 0 pairs. 1, 2. Now I do have 2 positive candies. So to complete my operation, I take them away. And I am left with 9 red candies. So -9. Now, once again at home, I want you to try this problem on your own. I want to use these candies to illustrate 7 minus 11. So take a moment and think about it and tell me how you would do that. Everyone ready? Okay. Now, if I have 7 minus 11, then what I would want to do is take away 11, but I don't have enough here. I've only got 7 yellow candies, so I can't take away 11 of them. So what I'm going to do is I'm going to add 0 pairs. So 1, 2, 3, 4. Now that might be enough. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so now I have 11 yellow candies. So I take them away. And what I'm left with are 4 red candies. So that means that 7 minus 11 is -4. The main advantages to this method are it's very visual, just like before. So if you're having trouble with negative numbers, then this is something that would probably help to illustrate it in a way that makes a little bit of sense. It's very intuitive to do math with physical objects like this. And so then it just becomes a matter of counting for the most part. The main disadvantage of this method is that while you can use drawings to represent it, it doesn't work quite as well as actually having physical objects with you. So if you don't have the starburst, then it's not going to be as easy to use. Also, just like with the number line, it's not really practical for operations with big numbers. For example, if I had 105 minus 120, then, I would need a lot of starbursts for that. A lot more than this. And even if I had that many starbursts, it would be really impractical to use this method for something like that. However, for small numbers, it's a really nice method to help illustrate some of the cancellation that happens when you add positive and negative numbers together. So that's very useful. Method number 3, using addition and subtraction rules. Now, using the addition-subtraction rules, in my opinion, is the most useful method out of the 3, and is the one that's the most applicable to apply in any circumstance. But it is a little bit more advanced than the other methods. And so normally, if you really struggle with negative numbers, you would probably use one of the first 2 to kind of get an idea of how the operations relate to each other. But then, once you became more comfortable, this method would be the easiest to use. First off, to use this method, you really have to get the idea that adding a negative is like subtracting a positive, and subtracting a negative is like adding a positive. In fact, you're going to use that to actually change your problem so that it only uses addition. So for example, something like this, where you are subtracting a positive, you got to change that to adding a negative. And something like this, where you're subtracting a negative, you have to change that to adding a positive. Second, you have to understand something that we call absolute value. Remember when I said that we can have big numbers that are negative and big numbers that are positive, and that I would discuss that later? This is later. So the absolute value of a number is how far that number is away from 0. So for example, the number 10 is 10 spaces away from 0. But the number -10 is also 10 spaces away from 0, just in the other direction. Whether your original number is negative or positive, your absolute value is always going to be positive, because absolute value is a distance, and distance is always positive. It's never negative. A distance can't be less than 0. If I have 2 numbers, and I informally describe one of them as bigger, then what I'm usually saying is that that number has a greater absolute value. And if that bigger number is negative, then it would technically be less than the other number, but it would have a greater absolute value. So let's bear both of these in mind before we continue. So let's think about some of the things that happened when we added numbers using the second method. If both the numbers we added were positive, then our result got bigger and it got more positive. So we really were adding those two groups of candies together. The same thing happened when we added two negative numbers. Our answer got bigger even though it got more negative. So we can treat both of these cases as though they were just regular addition. Well, the first case is regular addition, but besides that. If I'm adding two negative numbers, then I can just add them as if they were two positive numbers. I just have to remember that my answer is negative at the end. Now, what about cases when we were adding and one of our numbers was positive and the other was negative? Do you remember what happened then? The zero pairs would always create some cancellation, and we'd actually end up with less candies than we started with. This is just like what happens when we subtract. So even though we're adding, we can think of using these two numbers as though we were in a subtraction problem. Now, how do you know whether the answer you have at the end is positive or negative? Well, it depends on which of your numbers was bigger. That is, which one had the greater absolute value. If your bigger number was positive, then after you had canceled everything out, all your negatives would be gone, but you would still have some positives left over, so your answer would be positive. And likewise, if your bigger number was negative, then after you'd canceled everything out, all your positives would be gone, but you still have some negatives left over, so your answer would be negative. So if in your addition problem you have one number that's negative and one number that's positive, then all you have to do is subtract them as if they were both positive numbers. And the sign, positive or negative, that you'll have at the end will be the same sign as the sign of your bigger number. Now that still seems like a lot to keep track of, but have no fear, I made a chart for you. Now keep in mind that before you do this, you have to make sure you have an addition problem. So if you have subtraction, then you have to change that to addition by swapping the sign of your second number. Along the top of the chart, we have the possibilities for your bigger number being positive or negative, and along the side of the chart, we have the possibilities for the smaller number to be positive or negative. So let's look at each case. If both your bigger number and your smaller number are positive, then you just add them. Piece of cake. If both your bigger number and your smaller number are negative, then you still add them as if they were positive numbers, but you remember that your answer is negative. If your bigger number is negative and your smaller number is positive, then you subtract them as if they were both positive numbers, but you remember that your answer is negative. And finally, if your bigger number is positive and your smaller number is negative, then you just subtract as if they were both positive, and your answer is going to be positive. The disadvantage of this method is that it's a little bit less visual than the other two, and you have to be a little bit more advanced in order to be able to really use it. But if you set it up properly, then it's just as easy as adding or subtracting any two positive numbers, including ones that are much bigger than would be practical with the other two methods. And as someone who has practiced a lot of mathematics, this is the method that I personally use. When I'm having to subtract and add for myself and not for somebody else, then I'm usually not just, adding candies and things like that. Now that we've covered addition and subtraction, I want to just briefly talk about multiplying and dividing with negative numbers. The rules for this are a little bit easier to remember than the rules for adding and subtracting. They're just not quite as intuitive. First off, any strategy that you already use to actually multiply or divide numbers will still work even if some of those numbers are negative. For example, let's say that I have 4 times 5 equals 20. Now if I were to change my signs so that I had -4 or -5 or -4 and -5, the only thing that would change is that my 20 might be -20. The same is true of division. If I have 18 divided by 2, that's 9. And if I change the signs over here, the only thing that will change over here is I might have -9. So the only rules you really have to remember are what's the sign of your answer going to be? Do I end up with a positive number or a negative number? The straightforward answer is that if both of your numbers are positive, your answer is positive. If both of your numbers are negative, your answer is also positive. If one of your numbers is negative and the other one is positive, no matter which order they're in, then your answer is negative. Now, for some of you, that's going to be enough, and you can just stop there. However, if you're like me, you might be wondering, why is that? Why do those rules work that way? When I was in high school, I felt like that was the way it was, that I just had to remember that was the rule. Eventually I did learn, though, that there is a reason it is the way it is, and I'm going to talk about that now. The most common explanation involves the distributive property, which I'm not going to talk about just yet. But we're going to use a slightly different example. Back to the number line. Now, the way that you illustrate multiplication on the number line is by counting in groups. So for example, if I have 2 times 3, that means that I have 3 groups of 2. So that means I would start at 0 and count up by 2 3 times. 1, 2, 3. And so we end up at 6. It's also worth noting that even if I swap the two numbers around, I'll still get the same answer. 3 groups of 2 is the same as 2 groups of 3. So if I count it up by 3 2 times, start at 0, 1, 2. And so I still get 6. So to illustrate this point with negative numbers, we're going to try something a little bit different. Let's start at 3 times 3, which is 9. Now, if I were to decrease my second number, then that means I would move down 3. So from 9 to 6. 3 times 2 is 6. If I were to decrease it again, then it moves down to 3. 3 times 1, 3. If I do it again, now we're at 0. 3 times 0, 0. Now, if I were to decrease my second number again from 0, it would be negative 1. And by the same pattern, I move down another 3. So that means 3 times negative 1 is negative 3. And I could continue on if I wanted. I could go from negative 1 to negative 2, go down 3 more, and now I have negative 6. Now that's all well and good, but what about the weird example where two negative numbers multiplied together is positive? Well, remember, we can swap our two numbers and still get the same answer. So 3 times negative 3 is negative 9, but negative 3 times 3 is also negative 9. So what we're going to do is actually the exact opposite of what we just did. We start with negative 3 times 3 is negative 9, and we're going to count by 3's, up this time. Negative 3 times 2, negative 6. Negative 3 times 1, negative 3. So my second number is decreasing, but my answer is actually increasing. Then I get negative 3 times 0, which is 0. And if I do this again, then my second number will be below 0, so negative 1. But my answer will have gone up past 0 to be positive 3. Negative 3 times negative 1, positive 3. And again, if we wish to continue, negative 3 times negative 2, positive 6. Negative 3 times negative 3, positive 9. So that's to illustrate the basic principle of how these signs work. The reason we know it works for division as well is because, as we discussed last week, division is just multiplication in disguise. So remember, when multiplying or dividing, two positive numbers, positive. Two negative numbers, positive. One positive and one negative, negative. And that's all for this week's episode. Next time, we'll be talking about arithmetic using rational numbers and fractions. So don't miss it. Thank you for watching. If you enjoyed this week's video, please like, comment below, and share the link. If you want to see more, subscribe to our official YouTube channel and follow us on Twitter at Edumacator.